Part 3. Perception of light and colour. To see the colours around you, you will need three things. You will need an illuminant, or light source. Without light, everything will be black. Without light, it would be impossible to distinguish the object. The light source could be the sun or some artificial light source. Besides a light source, we also need an object to reflect the light. The properties of that object will affect the way the light is reflected from the object. For example, the mix of pigments or colorants will affect the wavelengths of light that are absorbed or reflected, and the surface texture, curvature, how that light is reflected. Finally, this reflected light must reach an observer. That's you. Your eyes capture the light, while your brain will make sense of what you're seeing. At this point, I should mention the CIE, the International Commission for Illumination. The CIE is an international body who research and standardise things like the standard observer, standard illuminants, etc., which are the basis for being able to measure and express colour digitally. You can check out their website via a link in the description if you want to learn more. Light is energy within the electromagnetic spectrum, and the distribution of that energy, depending on its source, will be different. You're probably familiar with this from your own home. Some light sources have a redder or warmer hue, while some appear to give off a bluer or cooler light. Indeed, even sunlight is different at different times of the year, or in different weather, or in different locations. As these light sources have different spectral power distributions, the energy that is available to be reflected or absorbed by an object is also impacted. So, without control of the light source, we do not have control of the colour that a human observer perceives. Within industrial colour and lighting, we use what are called standard illuminants, which is to say, known spectral power distributions for common light sources. Most commonly D65, which is a representation of circa central/northern European noon daylight at 6500 Kelvin, which is a relatively even distribution throughout the spectrum. You will likely also use other standard illuminants, such as illuminant A, which is an incandescent bulb, and F11, which is a fluorescent white. We now also have a range of standard illuminants for LED lighting. The variety of objects around us is seemingly infinite, and from the perspective of visual appearance, there are several factors that affect what we see. The pigments and colorants affect what light is absorbed or reflected by the sample. The surface and shape of the material affects how the light is reflected or scattered by the surface. The opacity of an object will affect the extent to which light passes through an object, to a backing material, or to the space behind. As observers, we are also inconsistent and imprecise. Human vision is affected by many factors, including sickness, age, sex, heritage, and experience. We have little colour memory and imprecise systems for communicating colour. Inside our eyes, we have a light-sensitive layer called the retina. This is your personal colour sensor. It senses both the brightness of the light as well as the colour. In the case of dim lighting conditions, you'll find that it becomes more difficult to distinguish between colours. This is because your colour sensing cells, the cones, only respond well if sufficient light enters our eyes. There are three different types of cone cells, each with different colour sensitivity. One type is best in detecting blue, the second green and yellow, and the third for red. Every observed colour will cause a different response of these cones. When the light is reduced, we lose our sense of colour, but even when it's pretty dark, we're still able to detect the objects around us. This is because a different group of cells take over from the cones, the rods. The rod cells are about 100 times as sensitive to light compared to the cones. However, they can barely distinguish between different colours. As no human body is exactly the same, also our eyes are different from each other. We all have a slightly different response to each colour. It may even be that someone's set of cones provide the same response for colours which appear different to most others. This is called colour blindness, and it occurs in approximately 1 in 12 males and 1 in 200 females. If you have any kind of colour vision deficiency, you probably already know it for many years. But if your job requires you to visually inspect the colour of products, it's wise to test your eyes regularly. Of course, you can always rely on a colour measuring instrument, which takes away the human component from colour evaluation. Colour measurement allows us to standardise the perception of colour, to create product colours that are pleasing to the human observer, and to obtain data that corresponds with what an average human observer would see.